It makes it almost useless.
Yeah, when I came in here, actually, for the first talk, I overheard some guys actually talking about finishing their master's thesis and then working for DuckDB. Congratulations, by the way. And it made me realize that that was a very long time ago for me, and it was actually here. So this is probably going to be a little bit sort of a grumpy old man talk about new things. Yeah, so that is these big data formats, which I hope you've ever heard of. If not, well, I'll tell you all about it. That's my colleague. So a little bit about me. Yeah, okay, so I spent some time here. I once worked at a company that only old people know, which had something to do with social media. It was really fun. Then I worked at Booking, where I met Daniel too. And then at some point, I managed to go to the big red evil, Oracle. And Martin never forgave me. Anyway, so yeah, but I am actually quite into open source, and I've always been doing that. But I do nothing with Parquet, ORC, or whatever, and I'm not going to talk about Oracle any more than I have to. By the way, I don't know anything about Oracle's internals because I have no idea how that thing works, and I really have no intention to learn. So yeah, so how did this start, right? We got hired for some reason at Oracle, and after some weird period, somebody just asked me, like, we want Parquet, do you know what it is? And can you build a connector so it can run in the database kernel, which is written in C? So I said, sure, why not? And well, then it was like, okay, can you give it to me in 3 months? And then, okay, sure, why not? Okay, that's basically how I then understood how Parquet works. And after that, I did Avro, also together with Eleni, who's sitting in the back, and then, you know, ORC, because why not? You're doing all of them or not. And yeah, so, and I did that very much from the columnar background that I got really here at this very place in the insane group at CWI, MongoDB, which some of you might know, I hope. And so I was looking at these formats from basically that theory of columnar approach and in memory and so on and so forth. And then this is, yeah, that's basically the headline. I think, you know, this is my view on how these formats work and how they are everything that's straightforward. Yeah, so I will add some comments in the slides. I don't do any fancy graphics like you did. I keep it very simple. I don't know, it's just my opinion, right? So don't quote me on this, except just for me. But I'm very looking always at you know, how can you do something efficient? How can you do it smart? Yeah, this is where when I implemented these readers from scratch in the C language, which is yeah, for many people these days not done, but that was something like, okay, you know, how can you do this very efficient? The short answer is you can't, but okay, that's whatever, right? So Parquet, I think Parquet is for those who don't know, that's sort of like the #1 format for external data in an object store or Hadoop or whatever. It's apparently, it's the thing. It's the best you can ever have, apparently. And it's basically some sort of binary format that is yeah, contrast to text files. Believe me, real customers really store ginormous amounts of text files, and they use that. I see nodding face, that's good. It's really true. And then you have Parquet suddenly, and that makes, you know, things like integers and timestamps, and you know, yeah, that is faster for some reason. I don't know what. And then, yeah, they call it a columnar format, which means that they actually just store some sort of vectors of bunches of, well, it's not even that, but they attempt to store like a bunch of numbers or values in one go. Yeah, I love the amount of magic that they invented to do this, which they call encodings. They are really very interesting. But let me first give you a sort of overview of how does a Parquet file work, because Parquet is it's very good, it's very fast. So one of the things that is very interesting and very good of Parquet is that it contains metadata. So there's metadata in your file that describes the data that you have, which is really good because it's some sort of index. The metadata is more or less restricted to max-min information over chunks of data, but it's already useful. So yeah, there is some sort of hierarchy, and this is actually the details, but I think the next slide holds this interesting figure, which basically says the same thing. So you have the whole file. And then at the end of the file, there you can basically have the metadata that tells you where you need to read inside the file, should you want to read anything. That's basically this part, and so you need to go to the end of the file to read it, and then you figure out like, oh, I need to read this amount of bytes, and then you can read this, and then you have to decrypt. Oh, sorry. You have to decrypt this meta information, which contains information about what kind of columns are in this file, what are the types in this file, and these things that they call row groups. Row groups are sort of sets of rows. They're basically a bunch of rows with sets of rows and then stored per column. So that are these column things. So in a row group, you have a column, and then a column is split into smaller bits, which are called pages. And then each page has a header, of course, because you need to know something about it. And then you have these complicated repetitions definition. I will go back to that later. And then you have values. So the great thing of this format, in my opinion, is that you need to at least read 7 layers of indirections before you can actually get to a value. That's really cool. When I started programming this, I was like, okay, let's see if I can read a value from this file. And I had to go all the way from here to finally read something, and then I was done. And I thought, I could start with just doing some small thing and just proof of concept, but that was impossible because you have to implement everything in order to actually read one value. I like that. So there's a bunch of units. That's the other things that when they designed Parquet, for some reason they went with these units, these row groups and the page sizes, and then you have the whole file in itself. Originally, this came from a Hadoop world, so they said, hey, a row group that should match like one of those disk slices that you had in HDFS. It was 128 megs, and then later they said, well, maybe we should do more. And then object stores came around and said, nobody cares. And then, I don't know. So currently it's something like 4 gigabytes if you follow any instruction, but whatever. Then the page sizes should be small, but they can actually be 120 gig if you want. Nobody cares. It's not restricted in any way. It's just basically you go as you flow. You read the metadata, you come to the conclusion, oh, I need to read this amount of data. Great, that's what you do. So the idea was that you have one large file, which has multiple segments in it, which you can read in parallel. That, of course, is a great thing. And in Hadoop, that worked, of course. But so the processing unit is this row group. That's fine. But when you talk about these sizes and you ask users, for instance, like what size did you use, then they have no idea, of course. And sometimes they tweak these sizes and they make the page size very big instead of the row group. And, good idea, maybe. I don't know. But it's very confusing. Only when you understand how they are implemented and what they do, these sizes give you any information. One thing I really like, because in object stores you need to do a fetch, and if you don't have a lot of memory, then you would like to read a file or an object from the object store in a streaming fashion. So Parquet is designed in such a way that you first need to make one request to read the end, and then if you don't want to do another request, you need to basically make a guess how much you're going to read from the end. So you might have the metadata, which sometimes goes wrong if you have a very large file or many columns or row groups or something, and that costs you an extra read. And those are very expensive, of course. So in your latency of retrieving the files, that means, and then afterwards you do that, you need to go to the front again, which is kind of inefficient. I don't understand why they didn't just put it at the front. Because the writer could just, do that once, and then the reader could many times after that benefit from it. But why would you? Yeah, so this metadata, it's thrift. I don't know. I mean, you should look it up. I had a lot of fun with it. There's a library for it, of course, but yeah, I work for Big Red Evil, and then you cannot, for licensing issues, use things that exist in certain licenses, especially if they're open. Kind of allergic to it. So okay, I had a lot of fun with it. It was like, okay, why, right? I mean, there's also JSON. What's the real benefit of this? Well, they were saving 3 or 4 bits. Okay, but in the metadata session, what do you care? I mean, I don't, but maybe that's because I don't know. I don't pay for it. I don't know, right? But yeah, so there is some sort of schema, and if you have a mismatch in that schema, or you don't read it, or you implement it wrong, or whatever, then it doesn't work. But yeah, that comes with the thing. Anyway, oh yeah, encoding. So if you go into these row groups and you have the columns, right, and the columns are written in pages, then the page can be compressed, and they like Snappy. Snappy is a great compressor. It almost never compresses anything. And I see so many files where a column is actually bigger in the compressed form than it is when you not compress it. But yeah, why would you, right? I mean, use compression. There's encodings in these things that think about dictionaries or run length encodings of values. They can be extremely smart, and then especially after you basically compress your data, they really like to call another compressor like Snappy to compress that. And yeah, then sometimes it gets bigger. It's really weird. But that seems to be over the point, right? Well, then of course one of the sort of more, I think, encryption. Encryption is a feature that most of the time commercial users like. I've never found anyone, but okay. It's there. It basically complicates things even more with AIS and whatever. And of course you can combine all of these, right? Because this is cool. Yeah, then there's one note that is, I think, Peter is more suited for explaining this, because there's some sort of Dremel encoding, which is super difficult to comprehend. There is something with a whole lists of numbers that define whether a value is defined at a certain level or not. I will not go into detail. It cost me various amounts of headaches to get things right. But I don't understand it because it can be done way simpler. But you will see that soon. So in my opinion, if I look at, columnar, and then, in this room, well, maybe 2 levels up, but anyway, we used to get educated on what is columnar. And then if you look at Parquet data pages and columnar, it's like, they're sort of encoded in a way. They're not, at least not to me, they're not really CPU efficient to read in any way. They don't feel very well. They're not really efficient. I mean, if I look at how much CPU time we spent actually trying to unpack these things, that's a lot. And the question is, why? Because if you would just simply take the raw plain values and you would apply ZSTD compression, for instance, you get also very good compression rates, but it's way faster. So the question is, why is it so complicated? And is it really truly columnar, or is it basically just chunking your data into smaller bits that are not consecutive arrays of things that you can read? And are you allowed to call it columnar by then? Well, I don't know, but it was a bit of a disappointment for me. So then ORC is very funny. I think I don't know exactly in the timeline when it came, but it is very much like Parquet. It is almost the same, except that they seem to have taken some of these lessons and used it in their implementation. So there's some terminology, which is basically blah, 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 and then they use protobuf because that's Google's instead of Thrift. Yeah, okay, but it's the same kind of interesting stuff. So I will skip that. But this is basically how a org file, and I just yanked this off their website, right? So I don't think I made any pictures here. This is just, this is standard. But what you see is that it actually is the same as Parquet, right? There's row group, which they call stripe, and then there's at the back, there's metadata. So for some reason, they thought that was still a very good idea. Focus on the writer, just push out pages, and then at the end, write some metadata. But what they do instead is that they actually have some index information for columns, which is pretty nice. If you only want to retrieve column, let's say 1100, you can actually look at the index and know somewhere in this bulk of data, you need to start looking. And then they do something extra interesting. That is that in the column where they store these pages, they actually have a bit that says if it doesn't compress, then we will just leave it uncompressed. It's super cool. In ORC, you never see any file that is using compression that is basically getting bigger, because they have a flag for that that says like, okay, this didn't work, let's not do it. I kind of like that because it sort of seems to indicate that they actually figured out themselves that it didn't work. So far, so good, right? And they also define some limits to things, which are clearly geared towards, if you read this, you can anticipate on how much memory you would need. And I think that's very efficient or very nice, especially if you are not a columnar reader. Because if you think about certain commercial database products, they are not columnar. So they need to have basically all the rows, that means all values from all columns from all the rows, which is not necessarily efficient. So at least with ORC, basically you get an indication of how much memory you would need. Okay, thrift, protobuf, whatever, all at the end of the file, great. We have the same kind of data types, but they did a nice trick, as in they sort of redefined whenever a timestamp starts, because they said, most values are from now. So why would you waste all of those bits with values that, from the past that you don't need? So they just restarted in 2015, and that gives them a great saving, right? Because lots of things, lots of zeros at the front. So yeah, that works. There's time zone support in it, which basically is a headache, but okay. Yeah, so they work with streams. So they have a very nice nested structure that makes sense. I mean, all of these files store kind of nested structures. It's like you store JSON, but with a predefined schema. That's what they do. And then, yeah, they are able, I don't know if that's on this slide or another one. I think the next one, yeah. So they are able to store multiple streams for a column, which allows you to do, well, things like this. You can encode nulls just in a separate column, which of course can become a bit vector. So that's pretty efficient to store. Yeah, you have the data, and then the data, so it's the base value, and then they have another column which will then store, let's say in this case for the timestamps, the nanosecond values. The advantage of that is, of course, that you just have two columns of a certain size that are easy to fit in, for instance, 64 bits architecture, and you can just read them and then do something with it. Yeah, they just do other nasty things with their encodings, which are really tricky. But the good thing is they document them way better. Where Parquet is basically documented in the code, ORC is more documented basically in their online documentation. So yeah, you can actually implement ORC without looking at any code. At least I did. Yeah, then so the third format is Avro. Avro is a non-columnar format. It's basically a block-based sort of transfer format. It's stream-based, but it has the delightful thing of a JSON schema. So there is no such thing as protobuf or thrift to encode something. You can just read JSON and try to process it. Then, of course, there's binary encoding for the data because that's more efficient. And they don't have metadata, so you can't do anything but read everything. It's just like a CSV file, but then binary, which is okay, right? Because sometimes you need to scan everything anyway, so who cares? Yeah, there is some rudimentary. The file metadata is some rudimentary key value thing, and you get very quickly to something which is the schema. And then the blocks are basically, here is a number of bytes that you will get. This is the number of records that's in that block. And then there is some 16-byte trailer, which is for synchronization purposes in case your file would get corrupted. Because they really want you to recover and resume or something. It's a stream. I think Kafka also uses it for some reason. Anyway, then the downside of this syntax, this is the JSON schema. But of course, they made it interesting. They allow you to do a lot of things, actually define your own types and then refer to those types and reference it. And well, there's all kind of complexity in it. If you don't understand the schema, honestly, you cannot read the file because the schema, the data is stored as the schema lays it out. So if you don't understand what these things mean, you don't know what you're reading. That's kind of a problem if you don't support some of these weird constructs because then you cannot read that data. But okay, at least we humans can see what it is. Yeah, so you can skip a data block because you know the size up front. I don't know why you would want to do that because you have no idea if you want to because there's no metadata, right? So you don't know, like in Parquet or ORC, like, hey, I have metadata that says this value will not exist in this block, therefore I can skip it. That's not the case with Avro. It can be compressed, of course, so it's trivial, right? You just compress the whole block and then, yeah, it's smaller, but so in that sense, it's very simple. It's basically just reading value by value, unpacking a binary encoding. And that encoding is actually also documented very nicely on the internet. You don't have to read code. You can actually find how they encode it. So recap, okay? Basically, Parquet and ORC are exactly the same. Avro is just different. But if you want to read a file starting at the front to the end, then actually Avro is your friend because you can just stream it in. Everything is in order. You don't need anything up front or anything. You cannot do that with Parquet and ORC. But of course, the missing of statistics is really, really a bad thing because that means that you need to scan everything. If you have 100 terabyte of Avro files and you want to do a query on it, you need to read 100 terabyte of data from your object store, which might take a while, even if you have a lot of bandwidth. So, but that's where, of course, Parquet and ORC are much more desirable for these things, but they do, these scattered reads are really annoying unless you have a lot of memory. So for me, right, and this is just me, remember me, has nothing to do with my employer. I think Parquet is overcomplicated. It's very hard to get it right. The documentation doesn't exist, or it is incomplete, or it is misleading. And many of the things they do, I just wonder why, right? And just to give you an idea, I also wrote, of course, the things to write Parquet files, and I just skipped out all except the simplest thing, and it every time beat the original that was highly encoded with everything. I just used Z as decompression, and I said "doi," and it was better than the original, right? So I don't know if they ever did a benchmark, right? But they're heavily invested on all kind of very complicated. Let's save 1 bit, and you just use Z as decompression. Done. So ORC really seemed to, took the lesson of that somehow at some places. Still doing all these kind of quirky things like the timestamp trick, and they have all kind of stuff with decimals where they, I don't know. I mean, they actually have a trick for skipping zeros and then trying to figure out when they should and should not. And I mean, super cool. But at least it's documented. So you can find about it by reading the documentation and not by having to hunt through unreadable code. So I see myself that there's a lot of CPU usage when you actually try to unpack this, and that's really if you compare that to, hey, here's an array of data and you can just scan over it, it's a lot of work, and you need to copy the data many times. simply because they're not in a way that you can read them. Sometimes you even have to restrict partial values and stuff. Yeah, to me, right? And that's because in the way that I have to work, we don't have unlimited memory. So I cannot basically read an entire file or a row group and say, oh, okay, let's process it, right? I don't have the memory for that. And then these files are really annoying because they allow you to go back and forth and yeah, that is not so good for performance, because in the end, if you want something that performs, then doing an HTTP request is not going to perform. Yeah, I think that the thing with the metadata, well, I already said, like, this is really, I don't know, but probably that was because it was a good idea. I don't know. It is just expensive and it's annoying, and you don't know upfront what you need to do. What I see is that it is right optimized, and that's really the lesson. I think if you do big data, I don't understand, right? It should be more about reading than about writing, but they made choices, both of them, to say, hey, let's focus on writing. Let's make writing easy, and then reader, yeah, figure it out, right? But maybe, I don't know, but for me, that is really weird, because I think reading should be, everything should be tailored towards reading it, because who cares about the process of writing it? If that takes a little bit longer, you only do that once usually. And even Iceberg doesn't do it, right? Because Iceberg redefine, well, whatever. Do you know Iceberg? No? Good? Oh, yeah, great. Yeah, I won't talk about it.
Iceberg uses Parquet files.
Yeah, amongst other
And
things.
Avro.
And it uses Avro too, yeah, and then JSON, yeah, you can make a choice, do something. Yeah, right. So anyway, yeah, that's that, right? I think there's, well, we had some issues with memory because everything blows up. If you read a row group of 100 megabyte, it can explode easily into something like 6 gigabyte. That is a problem. Yeah, okay. I think in Avro, what we see is that you have very small blocks, and that is also, of course, inefficient because you read all kinds of small blocks and then you cannot batch very much. But the good thing is for Avro that you can actually change that, because you can make your own size if you want. But the lack of statistics is, of course, yeah, that's really annoying. But it's good for memory. So what I would do, right, is I would basically make a hybrid of Parquet and Avro, which I actually once upon a Blue Monday did, and basically just store the metadata at the front of this Parquet file. Why not, right? And it turned out not to be a problem, but it does turn out that you can actually then just start reading from the front, and you know exactly where you need to jump to further in the file, which you can do by just reading or whatever. But and that's something that seems to be really I don't understand why it's not difficult, but that's what I think the perfect file format should do. And it should actually think about the reader, right? How much memory does the reader need to read something? And I think if you talk about an environment where you're talking about thousands of CPUs or threads or something, then 2 gigabytes per reader is maybe too much. I don't know, but it is a lot. And if you don't have to, why would you? So yeah, and you know, like, you know, just compress and don't do anything, because it works fine. Okay, that was my talk. I hope you learned something. If not, you know, this is I was yeah, I was having a lot of fun while creating this, and actually thinking back at the times that I had to debug this. So okay, who dares?
So my understanding is that Dremel encoding used in Parquet is very efficient for sparse data. Have you seen files that with such sparseness that it's like
No.
beneficial?
No. It's just a nightmare. It's a nightmare to me, and I've never seen any realistic use case for it. If you look at what ORC does, where it basically just stores for an array, it just stores another array, that says how many entries are in there. And that is so super trivial. That really is. And I think there's even an issue where you cannot define a null value at a certain place or something, I don't know. But it is not something that the only thing I've seen is bugs doing that. And that's because we cannot use the reference implementation, whatever the reference implementation does, right? Because we had disagreements with that too, but to me, it is not, so I think it is really not necessary. Okay, the MySQL guy.
No, that's my Halloween shirt. You talked a bit about the encodings in, I think it was Parquet. Have you seen and do you have an opinion about the latest publication of Benny Pavlo where he embedded WASM code to substitute encodings?
No, but upfront, I think it's a bad idea. That, I mean, if this is anything that is going towards these, how does Iceberg call these weird things, bit flips or something? But they want to, anyway, but that's again, it's some sort of binary format to, I don't even know if it's necessary, but okay, no, I don't like it. But like, I'm a grumpy old guy, right? So.
Well, I need to compliment you for that persona. You put it well in stage.
No, I don't know what it is exactly, so I cannot comment.
Thanks for the talk. I imagine there are readers for Parquet in most languages. What about ORC? Apart from your C implementation, what other languages can I read?
So Parquet, I think, exists in any language from C++ through Arrow.
But and ORC?
ORC, I think too, yeah, and Avro too. Yeah. The only thing is that my implementation in C, of course, is proprietary. So I cannot say anything about it, which I didn't. And yeah, we can compare it to the reference implementations, which of course I did. And to me, that looked very good. Which made me realize that probably there's a lot of things to improve. So should I ever retire and I have nothing to do, I could actually go and probably have a look, but probably some IP has to expire, I don't know. But yeah, it exists, you can use it, right? In all languages, I think.
The metadata at the end thing is weirding me out. So does that data contain anything that could have been written first, or is it at the end because it needs to write everything and there's some kind of statistics that it wanted to write?
There are statistics in it, yes. Yeah.
Okay.
Yeah, and if you are indeed in a hurry and you really need to push out your data through this HDFS Hadoop thing, yeah, then you can only do it at the end. Yeah.
Makes sense. Okay.
But you know, you could also spend a little memory and then say, instead of writing one giant file with 128 blocks, you could also write one file of 128 meg.
Makes sense.
With the metadata at the front. What's the difference? Okay, now you have to read multiple files. Okay, but that's why we have Iceberg. Because people do that anyway. But you could also say, hey, if I can spend 2 gigs of RAM, then just create it in those 2 gigs and then put it at the front. Then you know, oh, I need to calculate because it only takes this amount of bytes. But even that you don't have to do if you're lazy, because there may be gaps in Parquet files. That's totally fine. Actually, writers make gaps, which is interesting because the gaps are sometimes very big and take up considerable amount of space. But there are gaps in Parquet files that do nothing. And so you could actually reserve a gap for your metadata and then just put it in and say like, oh, whatever, we wasted 10K, I don't care. You could do that. So I don't think there's a very good reason why they did it, except for it seemed to be easy to do it.
Right.
Well,
Sounds like you made this.
one of the reasons, one of the additional reasons, in my understanding, is that in HDFS, unlike in blob stores, you could in fact append to files. So it would be possible to append to an already existing Parquet file.
Yeah.
And then write a new footer.
But then you would have to be able to append before the end of the file.
No,
No.
you just
skip it.
append.
You can skip the old-
footer.
The old.
Yeah, you leave the old
The
method
old
data in
footer is
place.
just
Yeah,
left
yeah,
there. Yeah.
yeah, yeah.
Hmm.
Yeah.
But yeah, we went to a world with blob stores where you
Yeah.
cannot append anymore.
You basically.
Well, actually, we can in
In-
S3 you can append now. Yeah,
Okay.
since
Okay.
recently.
Well, that's why they do it.
So you're not allowed to use open source libraries, but can you use things like address sanitizer? or similar?
Yeah. Yes.
Good to hear.
Yeah. Actually, and you know, this is I would say this is climate. I mean, I don't want to do hiring, but you know, this is what happened recently is that they understood that an SS or BSD license or an Apache license is actually not that bad. So the not invented here kind of thing, they catch up with that, like, oh, rewriting a lot of code is actually a lot of time. And if you can just grab it off the shelf, then maybe you should. So that is happening these days. So interestingly enough, right? So we wrote the Avro reader and now only, let's say 8 years later, they actually just include the Avro C library in Oracle. So I don't know why, because we had the functionality, right? But somebody needed it and now it's possible. Back then it was unthinkable, not okay. Couldn't do it. That's why we did it. So
Different departments.
yeah, I think
The
the
head lawyer retired.
No, I worked at MySQL when it was under Oracle as well, and we could take in the BSD licensed code. Because MySQL internally is actually, it's closed sourced, right? It just releases as GPL as well.
yes. By Oracle, right?
Yeah. Yeah, well, MySQL and Sun Oracle, Sun Microsoft
Now
for
Oracle.
that, so.
Yeah.
Are those file formats versioned in any way?
Yeah, they're all called version 1. Actually, I think 100 permutations of that, but they're all version 1. So I mean, yeah, there is a version in it, fixed.
So they can just put.
They need to make version 2. Yeah, no, you just change the format and tell nobody. That's what they do. That's why I like them so a lot, Parquet, because, you know, it's like, you know what? We'll just push a new feature. Oh yeah, Geo, whatever. We'll just change whatever schema and then we'll tell no one, right? Why would you? So, I think it's the exemplary project of how you should build a standard. I mean, there's only a couple of companies in the world that can do better, which I think number 1 is Microsoft, but even they start to sort of try and behave. So, but anyway, yeah, I don't know.
Ik werk niet meer.
Yeah, sorry, but it's true. I don't understand Word, really.
Nobody does.
All right.